Let's start with the problem based on last time. In a particular state, we won't name names here, charges on a payday loan may not exceed 15% of the amount advanced. So the idea of a payday loan is you just need money for a couple of days. You know, you're getting a paycheck soon, but I need to pay off an expense right now. So a payday loan is going to be paid back very quickly. All right, so the loan, the charges may not exceed 15% of the amount advanced. Find the annual interest rate R if $450 is borrowed for 7 days at the maximum allowable rate. All right, so you see this rate of 15%, and you say, okay, well, what's the annual interest rate going to be? Well, you'd say, sounds like 15%, right? Okay, well, let's figure it out. So, what can we use? Well, we can use one of our formulas. We can say we have the interest is equal to P, R, and T. All right? So the amount of interest you're charged, and in this case, we're thinking of interest in terms of the fee to borrow the money. It's equal to P, the principal, that's the amount borrowed, times the interest rate times time. So, what to do? Well, let's see, are there things that we know? What do we know? Well, first off, what are we trying to solve for? Do we know that? Well, we're trying to solve for R. Right. I think we missed International Talk Like a Pirate Day. That was, I think, sometime last month. But we're trying to solve for R. All right, so let's think about what we know. So, we have to know these other pieces of information. So let's just pick one. Pick a symbol. I, P, or T. And we'll talk about it. Okay, I. That's your interest. That's like the fee. What's our fee? Well, we're doing the maximum allowable rate. We're told the rate can't be more than 15% of the amount advanced, and we're told 450 was the amount that we borrowed. So, if we tie all of that together, what does I become? Becomes 15%, which is 0.15, times 450. So 15% of the amount borrowed. All right. Well, let's just move across. P. What is P? It's the principal, present value. It's the amount borrowed, 450. What is T? T is for time. We measure time in terms of years. We were told 7 days. We can think of 7 days, by the way, as 1 week. So, what would T be? 1/52. That's the portion of the year that you have to pay it back. So, we have 0.15 times 450 is equal to 450 times 1/52 times R. So we start with our basic formula, fill in what we know, and say, all right, now we just need to solve for r. What are some things we can do to get there? Well, we basically just have to move what's in front of the r across. Now notice that both sides have a 450. What does that do? They cancel. Because you can divide both sides by 450, right? It's the dividing by 450 that causes that cancellation. So you might say, well, wait, what does this number, how does it influence the answer? And it turns out it doesn't influence the answer. Whether you borrow 450 or 1,000 or 10,000, we'll still end up with the same r. Now, how do you move 1 over 52 across? Well, to move 1 over 52, multiply by 52. So you take 52 times 0.15, and that's r. And we don't have to do that in our heads if we don't want to. We take 52 times 0.15, and what comes out is 7.8. Okay, so 7.8. Now, is this 7.8% or not 7.8%? Because 7.8%, you're like, that sounds not so unreasonable. You only borrowed money for a week. Is this a percentage? It is not. How do we turn it to a percentage? Gotta move the decimal place over 2 spots. So this turns out, this loan, in terms of an annual percentage rate, you're being charged 780%. Now you might think this is a made-up thing. This is a very real thing. And lots of people use payday loans on a regular basis. Is that a wise financial decision? No. But just because it's not a wise financial decision doesn't mean that they have a choice. Some people don't have options. So payday lenders are often lenders of last resort. But this is why a lot of politicians tend not to be in favor of payday loans. I have to be careful to limit my comments. That's the opinions of Steve Butler, not of Iowa State. I'll say that. All right, so that was from last time. Now, a thought for the day. We are what we repeatedly do. Excellence, then, is not an act, but a habit. So, if you want to do well in something, you should strive to be consistent in practice. Athletes who compete in professional sports or the Olympics don't just show up randomly on an event day and have a good race. They've been preparing for it. Musicians, same thing. They just don't show up and have one good set. They've been practicing hours upon hours, days upon days. Well, it's the same with being a student, being a learner. If you want to perform well on a test, you don't just show up and hope it goes well. That's the act. You need to make it the habit. And you're doing what you need to in some sense. You're here. And I appreciate you for being here. Thank you. But also make sure that you put in the practice. Put in the effort. And it'll pay off. Now, what are we doing today? Last time we talked about simple interest. And simple interest is, we're going to compute interest at one point. All right? We're going to talk about compound interest. And you're probably thinking, haven't we talked about compound interest already? Yes, we have. So it's going to be a really relaxing day for us. So, what is compound interest? Well, compound interest is the idea of interest is allowed to build on the interest itself. So it's not just the principal that you're paying for, you're also paying for the interest that you've accrued so far. So how does it work? Well, the basic idea is to say, well, we know how to do simple interest. You take your current amount and you multiply by 1 plus a rate. What we'll do is we'll just do that again and again. So one way to think about it is you can say, well, I'm going to take 1 plus I. I stands for the rate per the compounding period. So as often as we compound, figure out, okay, what's that interest being charged, what's that rate being charged in that single period. And then you're going to multiply that every single time you get to a new period. So it's P times 1 plus I after you've reached your first period. Then times another 1 plus I, making it 1 plus I squared after your second period. Times another 1 plus I, making 1 plus I cubed, and so forth and so on. All the way up to however many you get. So we wrote this before as P times 1 plus R over M. So R is our rate, and M is the number of times per year that we compound. So that's why R over M is this I. And then M times T, well, that's how often we compound it. So that's why M times T equals N. Now, the more often you compound, the more opportunities you get for interest to build on interest. And of course, if you're investing, it's in your interest to try to have that happen as much as possible. You say, okay, I'm not just going to compound once a year, or once a month, once a week. No. I want to always have interest being accumulated. And so that becomes a different expression involving E. And so discrete says you're breaking up into a finite number of times that you're compounding the interest. Continuous says I'm doing it all the time. Never stop, never stopping. And so that formula is the A, which is the amount that you have, is your original amount, your present value, times e to the power RT. R being the interest rate, T being time. All right, so that's what we're going to do today. Hopefully, we'll be pretty good at it. We've had lots of practice. Any questions? I'm not going to do any theory beyond what I've said. The rest of today is more practice. So, if you have questions, now's a great time. But of course, as we do problems, if you have questions, that's also a great time. All right. So, determine the compound interest earned on a 5-year investment of $4,000 at a rate of 8%. If the interest is compounded, then we have a couple of possibilities: annually, quarterly, or monthly. All right. So we have our basic formula. So here we're in the, sort of our what I call the discrete. Do you have a preference? Do you want the R and the M, or do you want to do the I? We can do it either way. I'll do the R and the M for this one. So we have our amount, our future value, is our present value, 1 plus R over M to the MT. So let's think about what things we know. What things do we know for sure in this formula? There are some things which we won't know, because we have three things. Well, what pieces do we know? And you should think of, hey, I see numbers. Let's try to put them in. Here's a number, 5. Does that show up in our formula? And if it does, where? So 5 years, that's a big clue. Years is like a measurement of time. So that is showing up here. That's our t. Okay, so we have t equals 5. That's always going to be the case. All right, well, now let's do another one of these. Here's another number, 4,000. Does that show up in our formula? And if so, where? So that's your initial investment, your present value. That's your P. All right, so good. We've got P equals 4,000. All right, well, I see another number here, 8%. Where is that going to show up? Or does it show up? R. Indeed, showing up here, R. And of course, we change it from 8 to 0.08, right? We move the decimal place. So be comfortable with moving the decimal place. Because if you forget to move the decimal place, you go from like an 8% return to an 800% return. Now that's a really good investment. But okay, so we know those things. We've kind of run out of numbers. What about the M? Well, it depends, right? So let's talk about A. If we do it annually, what would M correspond to? So as a reminder, M is the number of times per year that you're going to get this interest compounded. So annually would correspond to what? Annually, once a year, M equals 1. Quarterly, what would that be? 4. Good. People are holding up 4 fingers. So I'm really excited to see what they're going to do for monthly. So for monthly, what would that be? I saw a collaboration there. It's like, okay, we're going to work together. Our fingers combined, we can get to 12. All right. So this is great. We have all of our pieces. So let's go ahead and we'll start with annually. So we have our amount that we're going to have in the future. That's 4,000. And I'm just plugging in what we know. Times 1 plus 0.08 divided by 1 to the 1 times 5. And this is a great chance for us to use our calculators. Great calculators. And of course, the big thing, be careful that you plug things in correctly. Be generous with your parentheses. 4,000 times 1 plus 0.08. And I know what 0.08 divided by 1 is 0.08. And then I'm going to raise that to the 5. And that gives us $5,877, and we round 31 cents. Now, is this the answer? And why not? It's not the answer. What is it we're looking for? It tells us determine the what? Determine the interest. It doesn't say determine what your investment is worth. It says what interest did you get? Now, this $5,877.31 is not just the interest. What does it also include? It includes the initial investment. So if I want to figure out how much interest I made, what do I need to do to this? Subtract off the 4,000. So That says the interest earned well, this you can do. If you subtract off 4,000, that makes it $1,877.31. So once per year, that's how much interest we'll earn. So we'll make a little note so we remember we subtract off initial investment to get the interest. All right. Well, that was annually, and the rest of them are going to be very similar. So hopefully we'll get into our groove here. We say, okay, quarterly, what changes? Well, we only have to change the M. So you get A is 4,000 times 1 plus 0.08 divided by 4 to the 4 times 5. Now notice, just a comment here, this says every time that you charge interest, you get 8% more added on. This says, hey, every time I charge interest, how much do I get added on? 2%. So you're splitting up and you're saying, oh, I'm only getting 2% each time, but I get it more times. So that's sort of the idea. The hope is if you get maybe less interest but more often, we should be ahead. Now, by the way, before we do any computation, should our answer be bigger or smaller than $1,877.31? Bigger. Yes! Yes! Bigger is correct. Why? We compounded it more times. The more often you compound, the more chances that you get to make money off of the interest you already earned. So, more frequently compounded, more money. That's good. So, we go through and do the same thing, 4,000 times, add a parenthesis, 1 plus 0.08, divide by 4, parenthesis, to the power, and 4 times 5, well, I think I can do that in my head, that's 20. And out comes a number, $5,943.79. All right. Well, same thing. That's not the interest, but we just subtract off our initial investment, and we say interest earned will be, if we subtract $1,943.79. So we made about $66 more. That's not bad. All right, last one. And in the interest of time, we'll just go through this a little bit faster. Again, the only thing that's changing is the M. So 1 plus 0.08 over 12, 12 times 5. And, all right, come on, clear, 4,000 times 1 plus 0.08, divide by 12, and 12 times 5, that's 60. That becomes $5,959, $9.38. And that tells us, lo and behold, our interest earned is $1,959.38. Again, we went up. Now, I will say it goes up pretty dramatically, as you start, 1 to 2, 2 to 4, versus from like 12 to 24. But still, it goes up. All right, any questions on this one? Okay. So, our next one. How many years will it take for an initial investment of $1,000 to grow to $2,000? Now, by the way, oftentimes you'll see questions like this. It's like the doubling time. How long does it take for me to double? So how long does it take for 1,000 to become 2,000? If it is invested at a rate of 6% compounded monthly, and then there's a second question, what if it's compounded continuously? All right. So let's start with the first one. It's compounded monthly. So we're in our discrete setting. So we have A, P, 1 plus R over M to the MT. What is it we're trying to solve for? Let's figure that out. What are we trying to solve for? T. Because it's asking us to solve for years. That's a time measurement. So we're trying to solve for T. Now, you might notice something about T. It's up in the exponent. When we have to solve for something that's upstairs, what will be our tool that we need to pull out and use? What do you need to solve for something that's up in the exponent? If you want, we can figure it out. If you don't have an answer, just give out a letter. L. Good choice. Oh, another good choice. G. Wow, you guys got it. All right. So if there's something upstairs that you have to solve for, often it'll be the R or the T kind of thing. T if it's compounded discretely, compounded continuously. R if we're talking about compounded. Well, anyways. But the punchline here is if you have to solve for something that's upstairs, logs are going to show up. So we're anticipating a log showing up. All right. So we have a bunch of numbers. And one of the things we can do is just say, let's go through and at least figure out how the numbers fit in. 1,000. That's our initial investment. What does that correspond to? P. P. That's where you start. 2,000. There's another number. That's what we want it to be. What does that correspond with? Oh, yeah, you betcha. You betcha. Okay. 6%. There's a number. What does that correspond with? R. And we convert to decimal. So R is 0.06. Now, that still leaves us with one symbol to play with, this M. And we've run out of numbers. Is there anything that tells us what M is? The monthly. Yeah, that's the clue for M. All right, so what does M become? 12. Because there are 12 months in a year. All right, so we have all our pieces. It's just we put it all in. So we have 2,000 equals 1,000 times 1 plus 0.06 divided by 12 to the 12 times t. Now, before we take a log, I would move the 1,000 across. How do we move the 1,000 across here? Divide, because there's a multiplication going on. So we get that 2 equals, and 1 plus 0.06 over 12 to the 12t. All right, we know what's coming. Log. Well, now it's just a matter of pick your favorite log. Do you like log log, log base 10, or ln log base e. And spoiler alert, in this case, it doesn't matter which one you use. Actually, it doesn't matter which one you use in any case, but sometimes natural logs fit better. Do you have a preference, ln versus log? I'll go with ln then. That's my default. So the idea here, we have two things which are equal. If two things are equal, then when we plug them into the same function, we'll get the same result. That's one of the properties of functions. If you plug in the same thing, you get the same output. Since we know that we started with two things which were equal, then if we do the same thing to both sides, we'll end up with two things which are equal. But now, the wonderful thing about logs. Why do we like logs when dealing with things upstairs? What's going to happen to this 12t? It's going to come down. So that's one of our nice properties about logarithms. So the 12t comes down in front. So 12 times t times log of 1 plus 0.06 over 12. And now we are almost done, because our goal was to solve for t. There's one single t. It's no longer upstairs, so that's good news. And it's just this number equals a number times t times a number. Now, okay, sure, there's some messy numbers, but that's when we get to use our calculators. So we solve for t. So t will be what? Log of 2, that's the upstairs, divide by 12 times log of 1 plus 0.06 over 12. So that's our computation. And now we just have to make sure we carefully enter it into our calculator. So I'll start log of 2, make sure I put parentheses in, and then I'll divide by, add some parentheses. I'm a big fan of parentheses. Parentheses are point savers. So 12 times, again, a log of 1 plus 0.06 divided by 12. I have to have a parentheses to there and a parentheses for my denominator. And fingers crossed, I counted my parentheses right. And this becomes 11.58. Well, let's round it to 11.6. So a little bit more than 11 and a half years. So it'd be like 11 years, 6 months, roughly speaking. Okay. Now, you should always sort of say, is that reasonable? Well, we know we're getting 6% added every year, roughly speaking, a little bit better than that. So we shouldn't have to go for like hundreds of years. If we got an answer in the hundreds, that's absurd. If we got an answer that said, oh, you're going to get it back in 2 months, that's absurd. But 11, it's like, yeah, I can kind of see that. I mean, worst case scenario, you got at least 60, 70% just from interest, and that doesn't even take the compounding interest. So always stop and ask, hey, is this reasonable? If not, check yourself. As the great mathematicians would say, you should check yourself before you wreck yourself. All right. So, what if it's compounded continuously? Well, let's think about the answer. Prediction. Let's make a prediction. Should it be bigger or smaller than 11.6? And why? So bigger or smaller? That's the first question. Maybe I should think of it, instead of bigger or smaller, think of it sooner or later. Will we be sooner than 11.6 years, or will it be later than 11.6 years? Sooner. Why? The more frequently you compound, the faster your interest grows. Since continuously beats monthly, we should be growing faster, which means that we should get there sooner. Now here the formula becomes a little bit simpler, right? We have our A equals P e to the RT. That's our basic formula. But we still have the same things for A. That's still 2,000. P is still 1,000. R is still 0.06. So we get 2,000 equals 1,000 e to the 0.06 t. All right. I'm going to do the same thing. Divide by 1,000. When does 2 equal e to the 0.06 t? Take the natural log of both sides. When does natural log of 2 equal natural log of 0.06 t? I got ahead of myself. Natural log of e to the 0.06 t. But what's another way to write natural log of e to the 0.06 t? This will become 0.06 t. Now you might say, wait, hold on. I thought you just said the only thing that happens is that your exponent comes down. And I'm like, yep, I agree with you. That's why it's 0.06 t. Then you might say, but wait, what about log of e? What is log of e? Log of e is 1. So this equals 1. Okay, so what do we get? Well, that says that t is the natural log of 2 divided by 0.06. And you might notice that seems like a nicer computation to carry out. And that's because it's a nicer computation to carry out. So we'll take our trusty calculator, log of 2, divide by 0.06, and we get 11.55. So yes, a little bit sooner probably translates to a couple weeks. But a couple weeks is pretty good. All right, any questions? Okay. How much should new parents invest now? It's like now. Invest it right now at a rate of 8%, so that in 17 years there will be $90,000 available for college funds if the interest is either compounded semi-annually or compounded continuously. All right, so these are responsible parents. They said, all right, college is going to be expensive. We want to make sure there's money to pay for it. All right, now the good news is 17, that's going to help a lot. And even the 8%, that's going to help a lot too. So that's good. So let's start. Do you want to do, we can do it in either order, A or B. Do you want to do A first, B first? A first, we'll start with A, all right. Now A is, we're doing it in finite breaks. So we start with our basic formula. So we're in part A. So A equals P, 1 plus R over M to the MT. So let's figure pieces out. First off, question. What are we solving for? Sorry, what? P. Yes! So it's how much should we invest now? So what's our initial investment? So this P, that's what we're solving for. All right, good. So this is what we're trying to solve for. Now, we have a bunch of numbers here. Let's just go through and fill those in. 8%, where does that show up in our formula? Shows up as R, and we convert it. So that's 0.08. 17, that's a number. Where does that show up, if it does show up? It's T. 17. Here's another number, 90,000. Where will that show up? A. That's our future value, the amount we're shooting for. Now, we've run out of numbers, but we haven't run out of symbols yet. We still need M. What would M be? What's our clue for M? It comes from this word, semi-annually, which means twice a year. So M equals 2. So we put all these numbers in. 90,000 equals P. 1 plus 0.08 divided by 2 to the 2 times 17. Well, this is a number. So what we can do is we can just move that number across by division. So it says the amount we want to invest now is 90,000 divided by 1 plus 0.08 divided by 2 and 2 times 17. Now we know some of these things. 2 times 17 is 34, but all right. We'll put it in our calculator here, our trusty calculator. Hopefully we can trust it. 90,000 divide by, parenthesis, 1 plus 0.08 divide by 2, parenthesis, and a little caret, meaning an exponent. And 2 times 17, we'll do that in our head, that's 34. And out comes a number, $23,719.69. All right. Is this reasonable? You should always check your answers, especially for this upcoming test, because when you start dealing with numbers, you shouldn't just be like, okay, it'll take me 800 years for my investment to grow. It's like, no, come on. If we had gone a number that said, you should invest 125,000, would we stop and say, maybe we made a mistake? Or would you say, oh, sure, 125,000? You would have made a mistake, right? Because investments are supposed to grow. So we know our answer should be less than 90,000, should be quite a bit less than 90,000, because we're going to get a lot of time for things to grow. On the other hand, if you said, you only need to invest $52, that would also be very suspicious. College is expensive. And so you have to think, is it reasonable? Save yourself some work. All right, well, let's do part B, compounded continuously. And so for part B, we have our A is P e to the R t, but of course the same symbols are the same values, so we still have the 90,000. We still have the 0.08 for R, we still have the t being 17. And so this becomes 90,000 is equal to, the thing we're trying to solve for, P, e to the 0.08 times 17, or P is 90,000 divided by e to the 0.08 times 17. So once more, I think this will be our last computation for the day. 90,000 divided by, we find our E button. Now, oftentimes the E's are tied to the log button. So in this case, you use the second log. For this calculator, all calculators are slightly different. Know your calculator. 0.08 times 17. Make sure your parentheses game is on point. And we get $23,099.47. So compounding continuously, you get to invest a little bit less than if you compound semi-annually. All right, we'll stop here.